is Uwe Himmelreich. I'm professor at the University of Leuven and I'm heading the biomedical MRI group.
My name is Chris Cawthorne. I'm a research expert in the group of nuclear medicine and molecular imaging, which is also part of the Mosaic core facility.
Mosaic houses almost all imaging modalities, including magnetic resonance, PET, SPECT, CT, ultrasound, optical imaging, but also image-guided radiotherapy. All these modalities are housed in one laboratory space, which makes multimodal imaging really possible, also enabling collaborations between the nuclear medicine group and the biomedical MRI group.
So the general goal of imaging studies at Mosaic is to provide imaging biomarker readouts in preclinical models over time. So these are longitudinal, non-invasive readouts that can be repeated. These can be very simple in nature, like for example, tumor size and how tumor size develops over time, or more complex things that reflect the biology and the physiology of the model in question, such as receptor density or blood flow in the brain, for example.
Bruker PET-MR system is the first system that allows simultaneous acquisition of PET and MR data. One obvious advantage is of course the intrinsic co-registration. So for example in motion-gated cardiac PET-MR applications, there the simultaneous acquisition of PET and MR data is essential. Another advantage of this system is also that it is highly flexible. So we can easily remove the PET insert and then use the wider bore of the 30 centimeter BioSpec MR system.
The main feature of the cubes is their small footprint, which means that we can have two cubes side by side, as you can see, next to the CT scanner, coupled with the mouse hotel, which allows us to image 4 mice per time in each scanner, or with 2 scanners, that's 8 mice or 2 rats a time. This really means that we can image the maximum number of animals per radiotracer synthesis. And this means it's very efficient for us and much cheaper to be able to evaluate novel tracers. The real advantage of again, with the small footprint, having PET, CT and SPECT, is that we can evaluate the imaging diagnostic part and then eventually also the therapeutic part to see what's the time course of this therapeutic drug in the same models that we validated its performance as an imaging biomarker.